Hello, I'm Lantop. This is the third part of the Pandas tutorial. In the last two sessions, we've discussed about Pandas tutorial. We introduced ourselves with Pandas tutorial, then we performed some analysis with Pandas libraries. Okay, in this session, we'll be importing a data sheet that will be used to demonstrate analysis and manipulation, data manipulation using Pandas library. Okay, let's get started. So I have this particular data in my folder, which is data.data, adult.data. This is the data I have in my library. I'm going to read it inside this Python environment using the Pandas library. So to read a data, make sure you have the data in your folder or provide the full path of the data. So I'm going to use the CSV function to read it, pd.read_CSV. Once you read the data like this, it's going to read as a data frame, something similar to this. And the entries should be exactly what is there. If you can visualize it with any spreadsheet software, so you see exactly the same thing in form of tables, arranged that is made up of columns, something like columns like this. That is how it's going to be read. So you have a data frame as the output. What exactly do you want to read? The file name is adults.data. I'm using read_CSV file because this is what is suitable for this particular file. But if you have some other file, maybe Excel format or XLX, or maybe XLXX file, then you can use read_Excel. That particular function is dedicated to Excel files. So once I read this, I'll have a data frame. This is what is in the data file. If I open it with any spreadsheet data. So these are the column names that I can see. These are the column names. I'm going to name this data is equal to this. Data equal to this. Okay. The first analysis I'll be making on this is to just to display few data. I don't want to display everything. It looks so big because I have so many rows, 32,000 rows. So I will just have the first 5 rows to be displayed for me to actually capture it, understand how it looks like. The first 5 rows, and I'm still going to display the last 5 rows. So to do that, you use the add function, data.add, this particular method provided in the Pandas data frame. So this is a Pandas data frame. It has a method which is called the add. So data.add is going to display just this, some part of the data. So this is the first 5 rows in the data. You can see 0, 1, 2, 3, 4. The first 5 rows in the data. But let's say you don't want the default is the first 5 rows, that add function. But let's say that I want the first 10 rows instead of the first 5 rows, then I'm going to provide the values. So then I have 10. So you can provide any kinds of values here. Let's say 15, 20, 30. Just display the first few numbers of rows and visualize it. I'm going to leave it as data.add. So we have this kind of data that looks like this. The state column, which are categorical data. This numerical data, bachelor. So as you can see, this particular row is also a value. So this could have been a value in this data set, like should have been the first values in the data set. So I have all this also, all this being highlighted. Let's say that I want to display the last few rows. So I'm going to say that data.tail. The data dot tail. Then this is going to give me the last few rows. Also, the default is 5. I can also provide 10 to display the last 10 rows instead of the 5. Okay, I'm going to leave this to be data like this, the tail. Okay, the first analysis that can be done is to understand what exactly is in each rows, what are the values in this particular rows, so which is the second row. Now I'll be pointing at the second row. Remember, we discussed locating a particular row, extracting a particular row, or extracting a particular column. So in this case, I'm only concerned with this column, the first categorical column, which is this. This is the first categorical column. You see that dot iloc. So the first categorical column is this iloc 1, which means that all the rows, and for the first column. So this is column 0, this is column 1, or for the second column, but we actually started indexing in Python from 0. So indexing start from 0, which is that 0 is column 1 and 1 is column 2. Index of 0 is column 1, index of 1 is column 2. So if I provided 0 here, I'm going to have the first column being extracted. So if I provided the index of 1, I'm going to have the second column. So I need this. I want to know this because this is a categorical data. Categorical data is not a numeric data, a continuous data like the first one here. So to know the values, I want to know how the values looks like. What are the scope of the values? So I can use the pd.unique. This unique function allows us to get unique values in a particular role or for a particular series. This is a series. So these are the unique values. So we just like this column, I think from description of the data, it's pointing at the categories of an adult. The data set is an adult data set. This particular column or this series data is pointing at the class, the kinds of work, the class of work, the employment role of that particular adult. Maybe it is self-employed, private, state government workers, federal government worker, local government worker, self-employed INC, or is without pay, or has never worked. So this is how the data set looks like. Okay, I can also do this for some other categorical data set. The next categorical data set is this. I think this is pointing at the level of education. So I'll see that pd.unique data iloc. So this is 0, 1, 2, 3. So I'm pointing at index of 3, colon index of 3. That iloc 0, 1, 2, 3. pd.iloc unique. Okay, I misspelled the unique. Unique is like this. So this is the unique. Okay, with this, once you want to perform your analysis, you want to check every columns, mostly sometimes categorical columns, or how your data set look like, the scope of your data set. So you want to describe your data set. What are the values there? Then to perform that descriptive analysis for categorical column, you just do something like unique to get the values in that columns, or you do something like what we did in the last session using descriptive analysis for numerical column or continuous column. Like the first column is data dot iloc, everything is 0. So I can use the describe dot describe. So this can be a way to perform a descriptive analysis for this particular column. This will allow you to understand how the data looks like, how that looks like. Okay, so let's proceed. Let's try to extract a subset data in this data set. If you look at this adult data set actually have this last column, which is greater than 50,000, just looking at the class of a particular row with all these properties of the adult, the age, the kinds of employment, and a lot of things like that. And the last column is pointing at if the adult is earning more than $50,000 or less than $50,000. This is what we have. Okay, so with what we discussed in the last session, extract the subset data, then we can use that to filter it, data.ilog. I will just be saying that -1, which means the last column. So I can see that is equal to less than, I can filter adult that earn less than 50,000 or less than that, greater than 50K, which is this 50K. So you have to be very careful once you are doing this. You can see that everything is false. Everything is false. So what I would just like you to do is just like copy it exactly like this, because some space might be included in the value, which you might not be able to. If you compare it like that, you might get everything to be forced. Let's try to put a space like this. You can see there's a space actually included. That's why you have a true value here. But if at all, if I've not understood, I didn't understand that there should be a space, I just try to visualize how the value should look like. Then I copy it. And another way you can determine that is to use the unique values. I can first do the unique values, pd.unique, that data.ilog. So I have this unique. You can see that there's a space actually that should be here for me to be able to extract the subset correctly. So now I can extract the subset. This is a Boolean column. I'm just going to index it with the data. So this is subset data. So this is subset data. Okay, in this subset data, I'm using the df subset. This subset data can also perform a new subset data. In this subset data, I can extract just data that are male or maybe female for a particular gender. This is gender, this is relating to gender. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can point at that ilog everything, 9. Let me see what I'm getting here. Yes, I'm getting gender. So I'm going to equal to, let me start from male alone. As everything is false, which I believe that the first one should be true. So I can find the unique value. So I can see if there are empty space that should be considered df underscore subset .ilog. So I can see there is an empty space that should be considered. So I'm going to put the empty space. With this now, I can extract the subset data. Okay. So this is the analysis. Let's say that I want to find the total numbers of males that earn more than $50,000. Then I can just see that len of this, len of 92 time, let me count it. So I have 6,662. So if I want to do the same thing for female, I just have to change this to female. Then I have a lesser number, 1,179. So that's what we call a simple analysis. this is much more complex than what we did in the previous one, like a midpoint analysis. Now you should know while working with pandas. This is so simple. It's this simple. You are transiting from this very simple analysis that we did in the last session, and this is much more complex than the previous one. Okay, so we have DF again. Our subsets look like this. Subset looks like subs DF underscore subsets. Okay, then we have, recall that we have our DF data that looks like this. This is our data flow. So we can perform an analysis, maybe those that are masters degrees that are any more than 50,000 or that are any less than 50,000. You can use for United States, for Cuba, different countries, or trying to find numbers of countries here, or those that are less than 50 years old that are any more than 50,000. So if I want to do that, I lock the first one. So less than 30. So this is going to give me subset data. So I'm using that subset when it got to this. So from this subset data, then I can also say that I lock -1. So this is going to give me the earnings equal to space greater than 50K. Greater than 50K. So subset 1. So if there's nobody that there's less than 50, there's less than 30, there's any more than $50, but we can't be sure. Let's put 50 instead of 30. Okay, maybe these particular values here, it shouldn't be exactly what you should put. I'm going to copy this and paste this here so that we should have, you can see. So you have to be very, very careful by providing the values because of some space that you don't understand. That's why I always get the unique value and put it exactly to where it is. So from here now I can find length. We have just 511 people that are less than 30 years old and any more than $50,000. So that is how data analysis work. That's how data analysis work. Okay, so in the next session, we'll be moving into a deeper analysis, a very, very deep analysis, like making plots using the Pandas library, making different kinds of plots, then making some other kinds of analysis, still with this data set that we are using. Thank you so much for this part.